Welcome to today's video on skip connections in neural networks. We're going to explore what they are, why they're important, and why they work so effectively. Before we understand skip connections, let's understand the problem they solve. When training very deep neural networks with many layers, we often encounter something called the vanishing gradient problem. As we backpropagate through many layers, the gradients tend to get smaller and smaller as they pass through each layer. This means that layers near the beginning of the network learn very slowly or not at all. This effectively limits how deep our neural networks can be. This is where skip connections come into play. Skip connections, also known as residual connections, were introduced in the ResNet architecture. The basic idea is surprisingly simple. We take the output of a layer and add it to the output of a layer further down the network. This creates a shortcut path for gradient flow during backpropagation. Let's compare a traditional block of neural network layers with a residual block. In a traditional block, the output is just a function of the input, hx. In a residual block, the output is the sum of the input and a function of the input x plus f, x. This function f, x, represents the residual or the change from the input. Now, let's understand why skip connections work so well. First, they make it easy for the network to learn the identity mapping. If a particular layer isn't useful, the network can simply skip it by making f(x) close to 0. Second, skip connections provide a direct path for gradient flow during backpropagation. Since the gradient can flow directly through the skip connection, it helps alleviate the vanishing gradient problem. How do we implement skip connections in practice? In a typical ResNet block, we have a series of layers with a skip connection that bypasses these layers. The most common setup is 2 or 3 convolutional layers, followed by batch normalization and ReLU activations. If the dimensions don't match, for example when downsampling, we can use a 1-by-1 convolution in the skip connection to adjust the dimensions. The introduction of skip connections revolutionized deep learning by allowing researchers to train much deeper networks. While networks like VGG stopped at around 19 layers, ResNets can be trained with 50, 101, or even 152 layers with improved performance. Skip connections have influenced many other architectures beyond ResNets, including dense nets, UNets for image segmentation, and transformers in natural language processing. To summarize what we've learned, skip connections allow gradients to flow directly through the network, helping solve the vanishing gradient problem. They make it easy for networks to learn identity mappings when needed, which helps with optimization. This simple technique enables training of much deeper networks with better performance. And skip connections are now a fundamental component in many modern neural network architectures.